Hello and welcome to another episode of LETP, or Learning and Understanding Electronics Through Simple Projects, or the shorter name LETP, standing for Learning Electronics Through Projects. This is the third episode of the series. In the previous two episodes, we designed these two little circuits. This is a charging circuit, and this is a protection circuit. And today, you're going to building the actual circuit, and then we're going to have some fun testing the circuit and seeing all the ways that I messed up and I have to now fix. And we're going to try to investigate why I made a mistake and how to fix that mistake. So, yeah. So here's the completed circuitry. This is what it looks like. It looks fairly nice, especially these two SMD transistors bodged onto two TO220 packages. This is the battery connector, this is the solar panel connector, and this is the load output. So we have input solar panel, then we have this Schottky diode, and that's this. This actually isn't a Schottky diode, it's just a fast diode, but that's what I found. Here's a P-channel MOSFET, that's the middle transistor, and this little transistor driving the base of this, it's right here. This op amp, that's this little chip right here, it's a dual op amp. Voltage reference 7805. I actually used 78L05, which is the same thing but in a smaller package. Because I'm just using it as a voltage reference and not as a source. This chip can deliver, I think, 100 milliamps, while this big one can deliver up to 1.5 amps. So that's the difference. Other than that, there is a whole lot. I added a lot of bypass capacitors. Those are these little things right here. It's just for circuit stability, but they are not that critical. The indicator is this yellow LED right here, and the voltage divider. As I said in the first video, I'm not going to use the two discrete resistors. I'm going to use a little potentiometer. So I'm going to have to set it up now. So the other circuit, here's our little fuse right here. The voltage divider is this potentiometer right here. Op amp, the same chip. This chip has two op amps inside, so that's it. A diode, it is right here, mounted vertically. The N-channel MOSFET is the third MOSFET right here. I didn't use the one I found in the ATX power supply because it was 40 amps, and I had this one from a motherboard VRM. It can handle up to 60 amps, so I decided to take this one. The two indicators are these two right here, and the little switch is these two headers, because it's going to be mounted on a panel or somewhere and not really on a board. So yeah, that's about it. I actually wrote what each wire is so I don't forget in the future, and let's try to power it up and see if something explodes. It is connected to a 12-volt supply, and when I turn it on, we have a red LED, so the circuit appears to be triggered, and the charging diode doesn't work. So first let's try, let me zoom in. First let's try to play around with the potentiometer for charging. It should light up when I turn it, maybe in the other side. Okay, so we see that the charging circuit indicator does light up, so I would assume that part is working. We are going to be testing it later with a buck converter, and an actual solar panel. I do have it available, so why not? And this circuit this potentiometer right here is supposed to be changing the reference the divider voltage for the output circuit, which is currently latched in the off position. Where are my tweezers? So if I try to reset it, nothing happens. That's probably because the potentiometer is set is currently outputting under 5 volts, and that's why it isn't resetting. And that's a good thing. That means that in case it triggers and the fault is still there, that means that you cannot reset it, and it is safer. So output of this potentiometer is currently at 2.7 volts, which of course would explain why it isn't resetting. 2.7 volts. Let's push it up to... Now it is at 9 volts and the red LED went out, which is not how it's supposed to behave. Let's see if I can reset the circuit. Actually, neither the green or the red LED is on, which isn't a good sign, because if we have a look at how they are connected, they go from positive. So even if I were to disconnect this op-amp completely, they would both light up, because the current will flow from the positive. The current will flow from the positive through the first LED, through the second LED, and to ground. So there is something wrong. If I reset it, okay, the red LED lights up again. That doesn't look right. Let me try to see what is wrong with the circuit. That's the positive rail feeding both LEDs for some reason. Why did I do that? I'm not entirely sure. But that will also mean that this output is not correctly hooked up. So yay, I messed up. So this is supposed to be the output negative, and if you follow it, it goes here down to the output of the middle transistor, which is battery positive. So while that is correct for a red LED, it's not correct for the green LED. Yeah. Oh, I messed up two things. Oh fuck. So the red LED was actually acting like a green LED in my circuit, and that's why it did light up red once again when I shorted the contacts. Frick. Alright, so I fixed the mess in the indicator section, and as you can see right here, you probably can see, let me fix that. As you can see right here, there is a little bridge and more bridges from here to here, and from here to here, from here to here, from here to here, because it was going like this, and this one went straight, and I needed to switch these two pins, which was very annoying to do, but if it works, I ain't complaining. Okay, Let's wire it back up and watch the fireworks. And now we have both LEDs. That's even worse. Fuck. Huh. That's not supposed to happen. Okay, so I have restored all the traces as they were, and now with the functional indicator I think this should work. I hope. If we rise it above... Why did you switch? Oh yeah, maybe I went too far, that's why it switched. Oh yeah! If I reset it, now it goes to green. I'm an idiot. I forgot. I am an idiot. What the fuck am I doing? This side maybe? Why does it go down? What did I do? It should jump to its normal voltage once I once I short this. And yeah, you see, once I short this, the green LED lights up, which is... The strange thing is, why is the red LED still glowing? 2.5 volts, that's strange. If I rise it above 5 volts, it's still at red, but if I reset it, it now latches at green. And that's good. And if I simulate the discharging battery, like by turning this potentiometer to output, and as soon as it hits 5 volts, the red LED should light up. And it did, and the voltage dropped way to 2.5 volts. So it's not latching it at 0.7 volts as I said, but it's latching it at 2.5 volts because of this resistor right here. And that's fine. Now that this thing is getting 12.6 volts, I should be able to measure 12.6 volts at the fuse here. I want this first potentiometer, which is this circuit right here. I want this voltage divider to output 5 volts when there is 12.6 volts on the input. So now we have 12.6 volts on the input, and I want to calibrate it. It's now outputting 5.3 volts, and we want to set it to 5 volts. Perfect. Okay, now if I connect our probe back to the source, and we see that the source is currently outputting 12.24 volts, and if I increase our battery voltage, our simulated battery voltage, as it's slowly charging, 12.49, 12.5, 12.2, and as soon as it reaches 12.59 volts, it turns off. If I decrease the voltage a little bit, our LED turns on, starts to charge the battery. See, at 12.6 it turns off, and at 12.55 it turns on. So I am pretty happy with that, how that works. So at 10.8 volts the battery is at 0 volts. At 11.3 it's at 10%. Oh god. Well, then I want to set a... I will not set our trigger voltage at 11 point... I want to set it at 11.58 is 20%. Okay, I am fine with that. 11.658 or 11.6. I'll give it... So I want this to be our minimum voltage. So now what do? Is we disconnect this probe, and actually we can do it just using the potentiometer. We can just use it using the indicator. So if I reset it, it goes back to... So if I increase the voltage above 5 volts and I reset it, now it latches green. And now, since our source voltage is at 11.6 volts, which we want it to be, to be the trigger voltage, I will slowly turn the potentiometer until it triggers. There we go. So now it doesn't want the reset. And if I increase the... where is the meter? If I increase the voltage above to 12 volts, if I reset it, it now latches green. So let's now slowly discharge the battery and see at which point exactly it triggers. 11.8 still fine. 11.7 is fine. 11.6. Okay, that was a weird trigger, but it did trigger. 11.62 is the voltage at which it triggers. So here's the example with the actual big lead acid battery. As you can see right here, it's a 12 volts 44 amp hour battery. It's a brand new battery, although it's dirty, and it is fully charged. So right now the circuit is triggered, and if I turn it on, it turns on. As you can see, the voltage drops just a little bit, and that's due to our internal series resistance of the battery and the dodgy cables. And now to demonstrate the previously mentioned that the thing I previously mentioned, that this circuit can also act like a short circuit protection, and I will do that using this 55 watt incandescent bulb. So if I connect it, the circuit just triggers again. Now if I take the tweezers and reset the circuit, the light lights up fine. And yeah, that's it. If I disconnect it and I connect it once again, the circuit will trigger again. And I'm actually fine with that. If you do not want it to react this quickly, you just add another... You can add another capacitor in parallel with the voltage divider, and it should delay the triggering. This is the battery voltage, this is the charging current, this is the battery, this is our load, this big light bar, this right here is the solar panel, and there is sun currently. The battery is about 12.6 volts, so there is no charging current. There is the battery isn't charging. The output is currently off. As you can see, the red LED is on, which means it's latched, and the yellow charging LED isn't glowing. Now if I short these two pins and unlatch the circuit, the light bar now turns on. and the battery slowly starts discharging. Now if I were to connect a higher load, where is my higher load, such as this 55-watt incandescent bulb. So as this incandescent bulb, as you can see, as the voltage is dropping, the charging current slowly starts creeping up, and if I connect a 55-watt bulb to the output, the charging current jumps all the way up to 2 amps to compensate for the load being connected. So it's trying to maintain the 12.6 volts voltage, but the solar panel isn't generating enough voltage for it to maintain 12.6 volts, so it is dropping. And if I let go, it is charging and the current is dropping, trying to stabilize at 12.6 volts. Like that. And that's our circuit working perfectly.